Hi everyone, in this video we're going to go through the rest of 4A because the first video was 45 minutes long. Oh my gosh, sorry for going so much over time, but graphing does take a while. I have finished all the solutions, so you can check out the completed notes so you can check whether your graphs are drawn correctly. I did do most of them using the quadratic formula. Some I use completing the square. It's not necessarily that one is better than the other. There's a lot of work there for both of them. I just thought I'd have a variety really. I do think like examples such as, which one did I do with completing the square? Which we did do, this one here, question E. You're working with fractions a lot and you know, you could make an error. A lot of these are quite complicated and I don't think you'd probably get as complicated as this, but it's good practice, especially with your fractions, adding and subtracting fractions or even multiplying fractions, dividing fractions I had to do. You could see on this one I did 24 times 18, so I had to do a little bit of long multiplication. So just making sure, these are skills that you have, just making sure you take your time and try not to make any errors, especially with your negatives. I made a few mistakes with my negatives. Okay, let's move on to question 2 before we have another 45-minute video. All right, so in question 2, it's asking without sketching the graphs of the following functions, determine whether they cross, touch, or do not intersect the x-axis. So for this one here, we're just going to use the determinant, which is b squared minus 4ac, and I don't know whether you saw that go blank, but I don't think my computer is liking all the memory I'm using. So I might just do a few of these and then you can get the gist of it basically. So for question A, let's just identify A, B, and C. So A is the coefficient of x squared, which is 1. B is your coefficient of x, which is -5, and C is your constant. So we just substitute that into our discriminant formula, not discriminant, our determinant. No, our discriminant. I always get discriminant and determinant mixed up. Discriminant. Okay, determinant is what we've used before doing matrices. Discriminant. Okay, sorry if I've been saying determinant, discriminant. All right, b squared. So we've got -5 squared. Make sure you put that -5 in its bracket because we're squaring the whole thing. And then -4 times 1 times 2. Now I didn't put that in brackets because there's no negatives, but if you like to do so, you can. So -5 squared is positive 25. 4 times 1 is 4 times 2 is 8. So we're going to have -8. Which is 16. Now 16 is greater than 0, so we're going to have, they cross, okay, so they cross. I'm just seeing what the question's asking. So they cross, okay, so therefore we've got 2x intercepts. All right, so that's basically all question 2 is asking. Let's do B and hope that we get a different scenario. So -4 for A, B is 2, and C is -1. So again, we're just substituting it into the discriminant. So B is 2, so 2 squared minus 4 times A. So this is where I'm going to put brackets around, -4. And then we've got another -1. All right, so 2 squared is 4. Just making sure I haven't accidentally written anything incorrectly. All right, so -4 times -1 is +4. So 4 times 4 is 16. So we're going to have -16. So it's going to equal -12. So because it's a negative number, we have no x-intercepts. It does not intersect the x-axis. I'm going to skip to question D, because I noticed it there. All right, I'm not going to do them all because you can check your answers in your textbook. All right, make sure that your equation is in the form x squared plus x plus c. Oh, you know, x squared is first. So we're going to have negative 2x squared minus 3x plus 8. Okay, a, b, and c are your coefficients and your constant, not the order that it's written in. So your value of a is negative 2, b is negative 3, and c is 8. It's very rare that you wouldn't get it in the right order. Maybe you've done it yourself. All right. When I was correcting one of your old tests, it was a question, a linear equation with a gradient, and students weren't realizing that it had to be in the form y equals mx plus c for you to read the gradient. So yeah, maybe I should make this assumption. It's got to be in this order to get a, b, and c. All right, so your discriminant b squared, so negative 3 minus 4 times a, so I'm going to be doing a negative 2 times c. All right, negative 3 squared is 9. 4 times negative 2 is negative 8. Negative 8 times 64 is negative 64. So I'm going to have 9 plus 64, which is 73. So they cross, therefore 2 intercepts. All right, the question is asking what the scenario is, so you don't actually have to add them together. You just need to know whether it's positive, 0, or negative, really. All right, now I want you to do the rest of question 2. I'm not going to do them because I feel like this question you've done since year 10, question like that. All right, question 3, however, is slightly different, but we still use our discriminant formula. So going to identify the value of a is m. Cool. All right, I feel like my computer is not liking all the memory it's using. So I might just have to save and start again. Oh, there we go, it's reappeared. All right, we'll see how we go. It does save as we go, so there we go. All right, so a is your coefficient of x squared, so in this case it's m. B is your coefficient of x, so in this case it's negative 2m, and c is your constant, so it's 3. All right, so our discriminant is b squared, so negative 2 squared minus 4 times m times 3. All right, so let's just tidy that up. So negative 2m squared. So negative 2 squared is 4, so it's 4m squared. Minus 12m. Now, if we've got two solutions, that means that your discriminant 4m squared minus 12m has to be greater than 0. Oops, sorry. I did have to delete a bit and I just realized that I deleted something I just spoke about. All right, so we have, for two solutions, we should have 4m squared minus 12m is greater than 0. Now, the problem with this is if we were to solve this, we're going to get m has to be greater than 0 or m has to be greater than 3. But when you think about it, m being greater than 3 is also greater than 0. But the problem with something like that is this m squared. All right, so let's just treat it as 4m squared minus 12m equals 0. So we're going to find our two values of m and then consider it graphically. All right, so I'm going to take 4m out as a common factor, and then I'm left with m minus 3 equals 0. So that means m is equal to 0 or m is equal to 3. Now, if I just quickly graph this, so m equals 0 and m equals 3. And this isn't the graph of the equation up here. All right, separate. This is just looking at the discriminant. So we're looking at values of m and the discriminant. So I've got 0 and 3. So think of this as a quadratic. All right, and I've just noticed that my computer's playing up again. So let's see if I just, that sound doesn't sound good. All right, all right. Okay, there it's back again. Okay, so there's my parabola drawn twice, which is really going to annoy me. So I'm going to take it off and draw it again. Yeah, my computer is definitely running out of memory. It's not liking me doing all this drawing. There we go. All right, so your value of m is between 0 and 3. All right, you got to think when it's positive, when your discriminant is positive, think of it as your y. When are we positive for the y? All right, it's this part here. So your value of m is everything up until 0 and everything after 3. So what a weird diagram I've just drawn. So if we're looking at two solutions, m has to be less than 0 or m, it's supposed to be an r, m has to be greater than 3. All right, to get that positive discriminant. For question B, we've got one solution for x. All right, I might just have to scroll up a little bit so we've got a bit of space. All right, so you can see where we've crossed the m-axis, we just have one solution. Okay, so we're going to have m equals 0 or m equals 3. Now, we've got to actually test whether those two values actually work. So if we go back to our equation, all right, our quadratic from before, so I've just highlighted it. Now think about what would happen if I put m equals 0 into that equation. I'm going to have 0x squared minus 2 times 0x plus 3. So I'm actually changing that from a quadratic into a point, okay, because I'd only be left with a 3. So m cannot equal 0, m can only equal 3. All right, so your maths, which you're probably, you'll go ahead and just do your inequality, or you might just say m equals 0 or m equals 3. You actually got to think about it graphically, or think about, well, when I substitute it into the equation, is it actually going to work? So you can see there two separate scenarios where you'd actually have to consider the graph and also the equation. All right, so question 4, find the value of m for which 4m plus 1x squared minus 6mx plus 4 is a perfect square. All right, so if it was a perfect square, I'll just show you graphically. Oh, it's terrible axes. Perfect square actually sits on your x-axis, so it only has the turning point sits on the x-axis, so we've only got one x-intercept. So that means your discriminant has to equal 0. So in our equation, your value of a is equal to 4m plus 1, b is equal to negative 6m, and c is equal to 4. So we'll just do the discriminant is equal to b squared, so negative 6m squared, minus 4ac. So 4 times 4m plus 1 times c. Okay, so 4ac, b squared minus 4ac. So your a we need to put in brackets because we're going to be multiplying both terms. All right, so negative 6 squared is 36, m squared is m squared. 4 times 4 is 16, so we're going to have minus 16 4m plus 1. All right, and I might just do that again. 16 times 4, so that's 16 times 2 is 32, so 32 times 2 is 64. So I'm going to have minus 64m minus 16. Now remember, to have a perfect square, your discriminant has to equal 0. All right, we can probably simplify that a little bit. I'm just looking at it to see what values we can take out as common factors. Now, 16 doesn't go into 36, which is a bit annoying. 8 does. Just wondering if we could simplify it any further. All right, let's just take out the common factor of, no, 8 doesn't go into 36, does it? No. 4 does. This is where you got to kind of think on your feet. All right, so 4 goes into 36 9 times, into 64 16 times, and then minus 4. So we've now got 9m squared minus 16m minus 4 equals 0. All right, and then we just have to solve for m. All right, so I'm just going to use the quadratic formula. So I've got to identify a, b, and c, different a, b, and c as to before. So a, b, and different, this isn't the quadratic from before, we're just solving for m. A, b, and c. All right, so x is equal to negative b. So b is negative, so I've got to put a negative in brackets, plus or minus the square root of b squared, so negative 16 squared minus 4 times a times c over 2a. Oh gosh, it's going to take me a while. All right. Negative and negative gives you a positive, plus or minus. 16 squared is 196. And then what do we got? 4 times 9, so 36. 36 times 4, 72, 144 plus 144. Now, again, you probably wouldn't get something this complicated on your exam, but good practice to do all this. All right, 196 plus 144 gives us, what does it give us? 200, 340. I feel like I may have made a mistake here because I think the answer isn't as complicated as this, but anyway. All right, now that 340 we should simplify. I am just going to cheat and use my calculator. I feel like these videos are long enough. Oops. All right, so we get 2 root 85. Doesn't really seem like it's making it any easier, so I'm wondering if I've made a mistake along the way. I might just pause and check. And I knew exactly where it was going to be because I thought that square root would have to get to 400, and it is. Oh. So 16 squared is not 196. Silly Billy. All right, let's just go through all that. So that's 256. What is 196 is 13 squared? No, 13 squared is 169, so I think 14 squared is 196. All right. Anyway, fix that problem. 256, so that gives us a square root of 400, which is nice because that's 20. That's nice. I knew I had to have, couldn't have a third in there. So 16 plus 20 is 36 over 18, which is 2. And then x equals 16 minus 20, which is negative 4 on 18, which gives us negative 2/9. All right, now my m's changed to x's, which is a bit silly, so don't ever make that mistake. I should have left them as m. So m equals 2 or m equals negative 2 on 9. Now we're just doing a perfect square. Now because neither of them is 0, that's fine. Both of them are valid solutions. All right, and I think that's it. We're on to the next section, which is a bit blurred. So just recall that don't leave it as X. I should have been doing my working with M, but it is very late in the day. So your final answer, M equals 2 or M equals -2 or 9. So if I just go back up here, that just means we get a perfect square. All right, I think that's it. Bye.